For countless years following the Apollo and lunar endeavors, Earth's satellite guarded its mysteries while humankind redirected its attention toward alternative celestial bodies. The ultimate retrieval of specimens by the USSR in 1976 signaled the conclusion of a significant period. Then, almost instantaneously, the cosmic contest the China National Space Administration propelled a sequence of change orbiters and touchdown craft, christened after the lunar deity, to methodically scrutinize our closest astronomical neighbor. Their objectives fused scientific inquiry with tactical advancement, cementing China's ascent as a cosmic authority. Fresh, SpaceX launch vehicles ascended into the heavens. NASA formulated the Artemis Initiative, and China discreetly probed territories previously unexplored. Murmurs commenced concerning peculiar revelations on the moon's concealed hemisphere, what lay genuinely buried beneath the lunar grid, and what motivates this universal resurgence. To commence, we should furnish some background. China's investigation of Earth's satellite initiated comparatively lately, in the 2000s, adhering to a bold, incremental blueprint. Chang'e 1, dispatched in 2007, functioned as China's premier orbital lunar observatory. It generated a three-dimensional representation of the lunar facade and examined soil constitution. Significantly, Chang'e 1's apparatus discerned indicators of helium-3 within the an initial suggestion of China's resource aspirations. Chang'e 2 scrutinized prospective touchdown locales for the ensuing venture, navigating a mere 15 kilometers above the terrain to photograph potential landing zones and validate surface security. A subsequent orbital probe was propelled in 2010, equipped with superior. Merely 3 years afterward, China attained its inaugural, gentle touchdown on the moon. The spacecraft alighted on the Earth-facing hemisphere within Mare Imbrium, and deployed the U-2 robotic explorer. This constituted the globe's initial lunar surface contact since 1976, terminating prolonged quietude. Initially a substitute for Chang'e 3, it was reallocated for a journey to the moon's perpetually concealed hemisphere. Its objective: to become the primary spacecraft ever to achieve touchdown there, a feat no other nation had accomplished. U-2 traversed the ashen expanses, conveying an ultraviolet telescope, the pioneering observatory of its category positioned on the lunar surface. In 2019, Chang'e 4 was launched, a venture destined for historical significance.
China's systematic initiative showcased not solely technological capability, but also geopolitical aspiration. The CNSA, under direct military jurisdiction, pursued dual aims: scientific revelation and strategic stature. This depression lies inside the immense South Polar Basin, among the solar system's most colossal identified impact formations. The importance of the far side is profound. It perpetually faces away from Earth, shielded from our radio transmissions, and had persisted uncharted by preceding landers. Researchers had long aspired to scrutinize its primordial landscape in pristine radio setting, yet the technical obstacles were immense. Because the moon's mass obstructs direct communication, no probe can link with Earth from the far side, lacking a relay. Certain analysts contend China's concentration is propelled by the quest for vital resources, signaling the commencement of a novel lunar energy contest. In essence, beyond patriotic distinction, the fundamental incentive resides in the unclaimed wealth of our satellite: metals, aqueous deposits, and nuclear. Therefore, on January 3, 2019, Chang'e 4 descended into the unfamiliar darkness of the moon's distant hemisphere, executing a gentle landing within von Karman crater. Consequently, Chinese ventures commenced to unearth or unveil a plethora of findings, spanning exotic substances to intimations of resources potentially fueling future settlements. These discoveries ignite not solely inquisitiveness, but also furnish solutions to numerous enduring inquiries. Foremost, naturally, is the isotope helium-3, a prize within the dust and among the most discussed lunar assets. The uncovering of the enigmatic gel electrified the online sphere. What could be adhesive or fluidic on an atmosphere-less moon? Volcanic glass, meteoritic fusion, or something even more extraordinary? Chinese representatives initially withheld imagery, intensifying conjecture. When visuals were ultimately disclosed, they exposed a shimmering, ebony material gathered amidst the dust and stones. Scientists analyzing its spectrum classified it as breccia soil and rock, amalgamated by the thermal force of a meteoritic collision. Essentially, a section of glassy lunar stone, presumably abundant in minerals like olivine and pyroxene, had liquefied into a uniform mass, not precisely extraterrestrial ooze, yet still a captivating find. It mirrored melted regolith samples from Apollo expeditions, but was detected in an entirely novel locale. This sparkling fragment narrated a tale of high-energy impacts that molded the moon's hidden visage, seldom encountered on Earth. It abounds in lunar soil, implanted over eons by the solar wind. Theoretically, helium-3 could energize nuclear fusion reactors, supplying vast-scale, pristine power. Chinese investigators accentuated this prospect in 2020, yet not every revelation proved so foreseeable. Midway through 2019, U-22 operators observed something anomalous within a minor crater, a loose, textured area distinct from the encompassing soil. China presented an elegant resolution. A specialized satellite named Qi, positioned in May 2018 at the Earth-Moon L2 point, suspended beyond the Moon with constant visibility to both Earth and the lunar far side. This relay was crucial, from the instant change for initiated descent near the surface. Its landing directives were transmitted via moments post-touchdown. The probe signaled home utilizing this communications conduit. Regardless, the landing zone itself stayed in absolute radio stillness, a perfect site for innovative trials. Here, Chang'e 4 deployed its U-22 rover, which traversed the gray powder 12 hours post-landing. This is a premiere for humankind and a remarkable feat, commended NASA Administrator Jim Bridenstine, as American investigators lauded the accomplishment. Now, from the concealed hemisphere, U-22's lenses recorded a vista no human vision had ever witnessed intimately, a cratered plain beneath an obsidian firmament. The geology of the far side fascinated scientists. It lacks the shadowy lava oceans dominating the near side, instead showcasing a denser crust perforated with impact scars. By traversing it, the probe might finally assist in resolving a persistent query. Why do the Moon's dual hemispheres differ so drastically? Consequently, Chinese ventures commenced to unearth or unveil a plethora of findings, spanning exotic substances to intimations of resources potentially fueling future settlements. These discoveries ignite not solely inquisitiveness, but also furnish solutions to numerous enduring inquiries. Foremost, naturally, is the isotope helium-3, a prize within the dust, and among the most discussed lunar assets. The uncovering of the enigmatic gel electrified the online sphere. What could be adhesive or fluidic on an atmosphere-less moon? Volcanic glass, meteoritic fusion, or something even more extraordinary? Chinese representatives initially withheld imagery, intensifying conjecture. When visuals were ultimately disclosed, they exposed a shimmering, ebony material gathered amidst the dust and stones. Scientists analyzing its spectrum classified it as breccia soil and rock, amalgamated by the thermal force of a meteoritic collision. Essentially, a section of glassy lunar stone, presumably abundant in minerals like olivine and pyroxene, had liquefied into a uniform mass, not precisely extraterrestrial ooze, yet still a captivating find. It mirrored melted regolith samples from Apollo expeditions, but was detected in an entirely novel locale. This sparkling fragment narrated a tale of high-energy impacts that molded the Moon's hidden visage, seldom encountered on Earth. It abounds in lunar soil, implanted over eons by the solar wind. Theoretically, helium-3 could energize nuclear fusion reactors, supplying vast-scale, pristine power. Chinese investigators accentuated this prospect in 2020, yet not every revelation proved so foreseeable. Midway through 2019, U-22 operators observed something anomalous within a minor crater, a loose, textured area distinct from the encompassing soil. Concurrently, amid the grey desolation, Chang'e 4 also transported a miniature biosphere trialer, sealed vessel the dimensions of a pail, containing soil, seeds, and insect ove. In January 2019, mission researchers proclaimed a seminal occurrence. A cotton seed had germinated inside the enclosure on the Moon. The announcement included an image of a fragile green sprout emerging under lunar gravity, the inaugural flora in human chronicles, to develop on another planetary entity. It offered a symbolic peek into prospective verdant habitats. However, the diminutive plant endured briefly. 14 days post-landing, lunar night descended, and temperatures inside the container plunged to -52 degrees Celsius. Deprived of sunlight, the sprout perished as anticipated once heating ceased. Yet, Within those fleeting days, it verified terrestrial life can commence growth even in such remote, alien circumstances. Additional seeds, and even fruit fly eggs and yeast, were positioned within the biosphere, endeavoring to establish a minute ecosystem. Although they didn't hatch or develop before the cold arrived, the trial denoted a crucial landmark in astrobiology. It demonstrated astronauts might one day cultivate sustenance on the moon, an indispensable stride toward establishing enduring lunar outposts. As one scientist articulated, this is the inaugural instance humans have performed biological growth experiments on the lunar surface. A minute emerald leaf upon a barren grey globe transformed into a potent emblem of approaching potential. Reports of China's distant lunar triumphs disseminated swiftly across the global scientific fraternity, inciting a surge of conjecture spanning reasoned discourse to extravagant conspiracy notions. In Western nations, numerous academics acknowledged China's technical triumphs and its persistent quest for information. NASA, though barred by US statute from formal partnership with China, still swapped some lunar data and extended. Researchers keenly anticipated outcomes from Chang'e 4's efforts in lunar geology, and some initiated contemplation of potential third-party cooperation. The far-side landing was acknowledged as a broadening of humanity's lunar comprehension. Could China secure a benefit in uncovering resources or installing telescopes shielded from terrestrial interference? Such inquiries ignited deliberation at symposia and within governmental spheres. Concurrently, the mission's confidentiality and the innate secrecy of the lunar far side nourished less substantiated conjecture. Conspiracy notions proliferated on internet platforms and sensationalist headlines. Some pondered if Chang'e 4 had encountered something genuinely astounding, perhaps proof of alien relics or archaic edifices concealed from terrestrial scrutiny. When initial accounts of a gel-like material surfaced before image release, external commentators speculated wildly, proposing living entities or clandestine installations. Similarly, in 2021, Ututu perceived a cube-shaped outline on the horizon, swiftly christened the Mystery Hut. For numerous weeks, the internet hummed with jests and notions that the rover had found a monolith or alien edifice. The rover team engaged, utilizing the moniker Mystery House, but making no remarkable assertions. As Ututu neared over succeeding lunar days, the reality emerged. The cube was simply an unusually contoured boulder situated at a crater's periphery resembling a hunched rabbit. Fittingly, as Ututu translates to Jade Rabbit, beyond extraterrestrials, more tactical and credible notions exist. Observers note, China's cosmic initiative possesses military connections, provoking apprehension about plausible covert aims on the far side. The findings and insights from the Chang'e ventures yield several major consequences. Primarily, there is the viability of a lunar base. The program's achievements unlock the prospect of constructing a research station on the moon, potentially on its far side. Should humans establish an encampment there, they could experience unprecedented astronomy. The radio silence would permit listening to the cosmos without terrestrial disruption. However, the far side also signifies perpetual communications segregation. Future installations will probably depend on relay satellites like Queek. China intends to erect a robotic research station this decade, potentially employing 3D printing to fabricate structures from lunar soil. The far side is no longer unreachable. We might eventually observe habitats or observatories erected in locations eternally obscured from Earth. Some propose a base there could obscure operations or function as a surveillance or missile launch detection post, protected from Earth. Nevertheless, no proof indicates Chang'e 4 conveyed anything beyond scientific apparatus. Its payload was openly declared, incorporating contributions from Europe. Regardless, the timing and emphasis of China's exertions, as the US and additional nations also revisit the moon, has fueled discourse of a renewed cosmic contest. We now grasp that discoveries on the moon's concealed hemisphere are transforming future strategies not solely for China, but for all spacefaring nations. Beyond that, verified helium-3 deposits and other mineral revelations enhance the prospect of lunar extraction. If helium-3 can be mined substantially, it might transform energy generation on Earth. Chinese scientists approximate 1 million tons of lunar helium-3 could satisfy terrestrial energy requirements for 10,000 years, essentially resolving global energy and climatic crises. although this remains somewhat conjectural and likely decades from fruition. The contest for helium-3 is now a component of geopolitical tactics. The nation pioneering efficient lunar mining will acquire immense strategic leverage and energy. The concept is to construct a base, likely proximate to the lunar South Pole, in alliance with other nations. However, one query persists unresolved. Who possesses lunar assets? Presently, the 1967 Outer Space Treaty forbids sovereign assertions to the moon, but as nations prepare to mine resources, novel international accords or disputes may materialize. It's evident the nations spearheading the quest and utilization of lunar substances will exert significant sway over those regulations. China's lunar missions are establishing the foundation for evaluating extraction viability. For example, experiments have ascertained optimal techniques for warming lunar soil to discharge helium-3. Unsurprisingly, China's lunar initiative is bolstered by entities like the Atomic Energy Authority. The moon might well evolve into the Persian Gulf of the 21st century. Although the launched missions landed distant from the poles, the outcomes are linked to the wider search for aqueous ice. In recent years, multiple ventures have verified water ice within the moon's shadowed craters, especially at the poles. Water is invaluable. It can maintain astronaut life and be separated into hydrogen and oxygen for rocket propulsion. China's leadership has observed imminent landers would target polar zones to evaluate ice deposits. Soil analysis data from Chang'e 5 even displayed hydroxyl at mid-latitudes, implying solar wind embeds HO into the surface. With water and solar energy, a lunar settlement becomes considerably more feasible. China's blueprint envisions utilizing in-situ lunar resources, meaning astronauts or robots could excavate ice, liquefy it for hydration, and refine it into breathable oxygen and hydrogen fuel. On the far side, particularly within the South Polar territory, ice deposits might reside in perpetually shadowed craters. If confirmed, the decision to investigate the far side could yield dividends with the revelation of keys to sustainable habitation. Ultimately, the CNSA has delineated a trajectory where the Chang'e missions prepare for the establishment of an international lunar research station with crew in the 2030s. The moon has become the focal theater of the 21st century cosmic contest, unfolding presently. Post-Chang'e 4's launch, all principal contenders intensified their lunar initiatives. China persists with a mission sequence building upon its lead. In 2020, the subsequent spacecraft retrieved specimens from the moon's near side, including the youngest lunar stones ever identified. Then, in 2024, Chang'e 6 launched, returning the inaugural specimens from the far side. It penetrated the surface and conveyed roughly 2 kilograms of rock to Earth. These specimens are presently undergoing scrutiny and may unlock fresh perceptions into the moon's past, corroborating earlier mission instrument data. Following this, the 7th and 8th spacecraft generations are planned for the late 2020s, targeting the moon's southern polar territories. Their objective is investigation and potentially commencing infrastructure development for the ILRS lunar base. Chang'e 7 is anticipated to seek aqueous ice and examine the polar setting, likely employing a lander, rover, and perhaps a diminutive hopping probe to traverse craters. Chang'e 8 will examine technologies like in situ resource utilization, possibly signifying the start of outpost construction. By the early 2030s, the People's Republic aspires to establish the core of a research station at the Moon's South Pole, accessible to global collaborators functioning beyond the US-directed structure. Meanwhile, the United States has rejuvenated its lunar objectives via NASA's Artemis initiative, sustained by private enterprise and a coalition of allied nations. Artemis aims to repatriate US astronauts to the moon and institute a permanent presence at the South Pole. An unofficial endpoint exists: the initial crewed landing of this new originally slated for 2024. NASA's Artemis 3 has been postponed to 2025 and beyond. Realistically, the landing is anticipated circa 2027. Conversely, has declared intentions to dispatch takonauts by 2030, devising a novel heavy-lift rocket with a lunar shuttle. These are demanding schedules, and it's undeniable a tacit rivalry is in progress. In 2024, Chinese representatives for the first instance cited the US as a direct rival in the lunar contest, notable acknowledgement. A tactical CNSA report forecasts that within the next 20 to 30 years, China's ILRS and America's Artemis base will operate concurrently at the Moon's south pole. The setting is literally arranged in the identical location. Sunlit ridges above shadowy, ice-laden craters, a zone where both nations aspire to position their flags and erect their frameworks.